everybody's here, so let's get started. I'll start by introducing her for Space Day today, who is Margaret Carter, and she's from Lambton College in Sarnia. Margaret has worked as a researcher at the Canadian Space Agency and NASA, so she's going to be able to answer all sorts of questions about space today. We have other
people
campers
would like to go to space sometime. Put up your hand if you'd like to go to space sometime.
Put your hand up if you want to go to space sometime.
Good.
That would be pretty cool.
Yeah, that would be very cool.
So today the campers are going to be using their imaginations to make a spaceship. They'll be simulating the stars with Galaxy Play-Doh and building a solar system. So I'm sure they have all sorts of questions to help them get through these challenges. So I'm going to start with a question from New Hamburg. Do the campers in New Hamburg have a question to start with?
Yep, we do.
Yeah.
Okay, go ahead.
How long is a spaceship?
How long? That's a really good question. They come in different sizes, but if you think of a 5-story building, do you know any 5-story buildings?
Yep.
Have 5 floors, that's about how long they are. So they're pretty big.
Not as long as I thought, though.
So you guys
like a big plane. Yes. I don't think you're making one that big.
No. Before I go to any other questions, Margaret, maybe you can introduce yourself a bit more, tell us a bit more about your research and what's cool about your job.
Okay, all right. Well, as Anne said, I work at Lambton College, so I do teach. I'm a teacher, and I teach a kind of chemistry to people that work in plants, that take care of petrochemical plants and fertilizer plants, food plants, anything that makes a product. The research I did with the Canadian Space Agency had to do with foam. You've all seen probably styrofoam. You know that when you hold it, it feels warm. If you haven't noticed that before, next time you see a piece of styrofoam, put it in your hand and you'll see that it feels very warm. Styrofoam is used in packaging. I'm sure you've seen that in things that come home from the store, but it's also used on the outside of your house walls to help keep the warmth in the winter and keep the heat out in the summer. Though that styrofoam is made up of millions of very, very, very tiny bubbles that trap gas inside of the bubbles. And so we were studying how much effect gravity has on those bubbles. Now, we don't think about that normally, but have you ever watched a bathtub full of bubbles? If you've ever had a bubble bath, how many people have had a bubble bath? Lots of people. And you know that over time the bubbles disappear. They pop. And if you blow bubbles, you know that they float around for a while in the air and then they pop. The reason they do that is the soap and the water on the edges of the bubbles are draining downward. And then what's left on the top is so thin that the pressure inside the bubble pops it open. And that effect is from gravity. It's from the weight of the material that the bubble's made out of dropping downward and making the walls too thin. So what we were studying is how the absence of gravity changes bubbles, how bubbles form and how they behave as they grow. So in doing that, I got to fly in some special aircraft that flew in giant parabolas. Does anyone know what a parabola is? Have you taken that yet? It's like a roller coaster. It's like when you go up and down there. I see some hands, so some people who know what that is. So it's just like a roller coaster. And on the upward, if you've been on a roller coaster, you know how you feel like you're being squished down? that's in the special airplanes I was in. You experience twice your normal weight. So they call that 2G. G standing for the force of gravity. But on the downward, you're in free fall. It's like floating in space. And that's when we did our experiments. And we made foams that had never experienced gravity. Nice bubbles in those foams that didn't drain because of gravity. Does that make sense to you guys? Some big words there. Yeah? Okay. Any questions about that? Oh, good. I see thumbs. Great. Oh, no.
Okay. Thank you, Margaret. That's an aspect of space research that I never really thought of before. The insulation
Actually,
in that.
The unique thing about our project is that we were the first industry to partner with the Canadian Space Agency. Most of the work the Space Agency does is partnered with universities or military. But we're the first industry. We made insulation, and we were involved in the Space Agency. So it was exciting for the Space Agency as well as for us.
Yeah, very cool. So I'm going to go to another question from one of our camps. This
Sure.
one was submitted from Twitter from Brantford. So shout out to Brantford.
Hi.
They want to know, how do you fly a spaceship?
You fly it very much like an airplane. Have you ever been on an airplane? How many people on our video rooms have been on an airplane? Lots of people. And did you get a chance to see the cockpit? How many people got a chance to see the cockpit? Sometimes if you ask, they'll let you come up. Good, good. And you notice all the dials and readouts and then the steering wheel sort of thing, all the same in a spacecraft. So it's the people who are pilots move on to be to fly the space shuttles and the things up there.
Great. So a pilot could potentially go on to become an astronaut.
That's right. Yeah.
Cool.
Yeah.
All right. So Waterdown. I see campers in Waterdown there. Were there any questions for Margaret today?
Yes.
Great.
How many times does it take to go from the Earth to the Moon and to the Moon to the Earth?
So how much time?
How much time does it take to go from the Earth to the Moon in a rocket and come back?
That's a good question. It depends on the rocket. There's no easy answer. Depends on how much fuel you have in the rocket and the weight of the rocket. So if the way you can think about it is, if you are in a car and you're stopped at a stoplight and beside you is a big, big truck, who moves faster from the start?
You. The car?
The car, that's right. So the car being smaller can move a whole lot faster. And the truck being really, really big doesn't have the same power to move as quickly. So the speed that you get to the moon in and back will depend on how big that rocket is. Make sense?
Yes.
Good question.
Yeah.
So I have another question submitted on Twitter from our camp in Ingersoll. Shout out to Ingersoll watching the live stream. This is related to the planets. Why were the planets named what they are?
Oh, well, that's a very interesting question. The tradition from way, way back, hundreds of years ago, when they first started noticing the planets and realizing they weren't stars, the first people chose to use the names of the gods. I'm not sure if they're Greek or Roman. I've forgotten now. But Mars, Venus, Neptune, Pluto, they're all Roman gods. So they kept that, as they discovered more planets, they kept that theme going. Good question.
Yeah. Thank you. And another question from Twitter from our camp in Sudbury. Hello, Sudbury.
Hi,
This is
Sudbury.
related to the spaceships, and I think a question we all kind of want to know is how do you use a toilet in space? It seems like something important. If we're going to go to space, we should know.
Actually, that was one of the biggest training factors. And actually, we have some pictures. So there's a picture of me getting out of a airplane holding a white bag, if you can find that one. Anne has the pictures for me, and we'll put that up.
The red airplane?
Yes, yeah.
Okay. Yep, just a sec.
So part of the preparation for working in zero gravity was learning not to be sick. So first, needing to go to the washroom is one thing. Hopefully you won't have to in the time that you're up there, because I wasn't actually in the space station for a number of days. I was in flights that would last a few hours, and sorry, distracted. So you could go to the washroom before and hope that you didn't need to. So the bigger factor was nausea. Almost everybody, something like 70% of people, when they go into zero gravity, because it's like if you've ever stood in your yard and spun around, and spun and spun and spun and spun and spun, you get dizzy. And that's because there's things in your inner ear that help you know what's up and down, things inside your brain, and they get confused when you spin, and they also get confused when gravity disappears. So that picture you're seeing now, that's Bjarne Torgersen. He's one of the original astronauts. He's a professor at Western now. And he took me up in that plane that you see in the background I'm getting out of. It's just a two-seater. He's an acrobatic trainer. He's a pilot that teaches people how to fly in shows where they do loop-the-loops and spins and so on. And so he took me up before we went in the actual experimental plane in order to make me sick. That was the whole point. So the resolution from my end isn't good, but maybe you can tell I'm holding a white bag. I threw up in that bag. And and I threw up every single time I went up. And when you can't throw up into a toilet or into something else. So the first thing they have to train you is how to throw up into that bag and capture what comes out and not let it fly all over the plane and get into other people's faces and on the walls and everything else. That's a bit of the gruesome side of zero gravity. So in the same way, they had to train us how to go to the washroom in case it was necessary. And I don't think you need the nitty-gritty details, but it gets done.
It sounds like it's one of the more challenging aspects of space travel.
It is. You have to have a certain degree of physical fitness too. It's not just like a passenger in a commercial aircraft.
Yeah. All right. I'll go back to New Hamburg. Was there another question from the campers in New Hamburg?
How much fuel does it take a rocket to get off the ground?
Again, it's a good question. Again, remember when I talked about with the question of what time it takes to get to the moon and back, the amount of fuel depends on the weight of the rocket. So if it's a small rocket, it doesn't need as much fuel as a bigger rocket. Also, how fast you want to get there changes how much fuel you need. But it's a large amount. If you've ever seen a rocket they used to put it on TV all the time, but I don't know now if they do at all. But if you've seen a rocket take off and then there's sort of rockets on the side of it, it looks like 3 rockets all wrapped together. 2 of those, the 2 smaller ones, are just fuel. So it's about the same volume of fuel as the rocket and what's inside of it that's going up to space. Does that answer your question?
Yeah.
Good.
Cool. Thank you. So I'll go back to Twitter. Another question related to planets from Ingersoll. They want to know, what is the ring around Saturn made up of?
That's a very good question. That is made up of millions and millions and millions of rocks. They have different compositions, which is where the different colors come from. And they're like moons. They behave just like moons. You know that our moon spins around our Earth at a certain speed. You can see it at certain intervals, and it turns as it goes around and catches the light from the sun differently. That's why we get full moons and quarter moons. The rings of Saturn are made up of much, much smaller pieces than a whole moon, but there are some that are just as large. And they've organized themselves because of their gravitational pull towards Saturn into clusters that have certain colors that are uniform within that band, that have the same colors and ability to reflect light. It's a good question. It's very pretty too.
Yeah, very cool. So our time's coming to an end, but I do want to get one more question in here from Waterdown. Did you have one question to end the call?
I already
Do you have a question? No questions on our end.
Okay, not a problem. How about maybe New Hamburg? It seems like there's some campers there around the video. Was there someone who hasn't asked a question yet?
How far away are we from the sun?
You know what? I don't know. I have no idea. But we're a long way. That's a good question. Right. I don't know the answer.
All right, no problem. So thank you, Margaret, once again for taking the time to call into our today.
Nice to meet you all. I love your questions.
Yeah, those were good questions. So, campers, if you want to thank Margaret and say goodbye today.
Thank you.
Bye. Bye. Bye.